Hello and welcome, dear friends! In this video we will learn how to resize the box collider depending on the depth of its penetration into another box collider. This video is part of my project released on Udemy. You can find the links to my projects in the description of this video. You can also find discount coupons there. Take coffee and cookies, we're getting started. Okay, we have two box colliders. The first one is the icon collider and the second one is the player field collider. Nothing happens when the icon collider penetrates the player field collider. Unity sends messages to the console and does nothing else. I would like to slowly resize the icon image. The more the icon collider penetrates the field collider, the smaller the image size should be. We also see the message when an icon hits another icon. Unity in this case also calls the onTriggerStay method. It needs to be fixed, and it needs to be fixed before we add anything to the onTriggerStay method. Open the icon prefab. Okay, first I don't want Unity to fire trigger events when an icon hits another icon. To do this, I will use the layer collision matrix. Let me create a layer, only one so far, call it icon. Select the parent object one more time and select the layer we created by clicking on it. Go to project settings, find the layer collision matrix, let icon objects ignore each other. And that's it, let's go ahead. The icon object has three child objects. All of them are of image type. It is enough to resize the parent object to resize all its child objects as well. I'm not going to resize the collider since I'm going to calculate the intersection area between the icon and player field collider. Select the parent object and let's have a look at the scale property. If I change the value of any of the coordinates, the sizes of all child objects will change as well. At the same time, Unity reduces the size of the collider. That's not what we need. So, to resize all image objects, I need to create references to all child objects and resize them one by one. The bad news is that we don't know how much we should reduce the image size. We have to calculate this value. So, we have two box colliders. The player field collider is much larger than the icon collider. Let's call the larger collider field. The icon collider can enter the field collider from any side. The icon may penetrate the field from above, below, right and left. It can enter from every possible position. In all cases, we can calculate the penetration area. The penetration, or let's say the intersection area, is always a rectangle. The further the icon penetrates the collider, the larger its size becomes. When the icon completely penetrates the field collider, the intersection area becomes equal to the size of the icon. The intersection area is always a rectangle. Let's call vertices A, B, C, and D. We can calculate the area of a rectangle if we find the coordinates of its vertices. It is simple geometry. Unfortunately, the collider class doesn't have any method to calculate the area of penetration into another collider. We have to create this method ourselves. Fortunately, we only need to calculate the coordinates of 2 points, A and C. In this case, we can calculate the width and height of the rectangle using simple formulas. The area of a rectangle is equal to the product of two adjacent sides, width and height. Okay, let's have a look at point A and let's start with the x coordinates. If the icon collider enters from the left side, then we can refer to the x coordinate of the upper right vertex of the icon collider. Let's call it x icon. If an icon collider enters from the right side, we can refer to the x coordinate of the upper right vertex of the field collider. Let's call it x field. The value of the x fields will be equal to the x coordinates of point A. An icon can enter the field collider both from the left side and from the right side. We don't know which side it will be, But we do know that x1 will be equal to the smallest of two values, xField and xIcon. Indeed, if an icon enters from the left side, then we need to use the xIcon coordinates. The value of the xIcon in this case will be less than the value of the xField. If an icon comes from the right side, we need to refer to the xField value. Again, it will be the smallest value, since its value is less than the value of the xIcon coordinates. Therefore, it is enough to find the smallest value between the xIcon and xField. This allows us to avoid using conditional statements like if statements or else if statements. We'll see it in action soon. Now let's discuss the y-coordinate of point A. Again, a player can move an icon in any direction. An icon can penetrate the field's collider from above or below. When an icon goes through the top side, we must refer to the top right vertex of the field's collider, getting its y-coordinates. In this case, we will simply choose the minimum value between the points y-icon and y-fields. We know both of these coordinates since we can get the coordinates of collider bounds, and will not depend on the player's actions. Now let's have a look at point C. We'll apply similar logic to calculating its coordinates. When an icon goes through the left side, we must refer to the bottom left vertex of the field collider, getting its x-coordinate. When an icon goes through the right side, we must refer to the bottom left vertex of the icon collider. In this case, we choose the maximum value between the x-icon and the x-field coordinates. And the last coordinate we need to calculate is the y-coordinate of point C. Again, we have two possible values. When an icon goes through the bottom side, we must refer to the bottom left vertex of the field collider, getting its y-coordinate. When an icon goes through the top side, we must refer to the bottom left vertex of the icon collider. This time we also take the maximum value between two options. Nothing complicated. Okay, we can always find the coordinates of two opposite vertices. As a result, we can calculate the width and height of an intersection area. Having calculated the width and height, we can calculate the area of any rectangle. Let's go for it. The player field object has a collider. Let me create a script that will manage the behavior of the player field object. Call it player field. Add the script to the player field object. Well, the collider class doesn't have a method that allows calculating the intersection area. However, the collider class has a property that refers to the bounds of a collider. It is the bounds property. According to the definition, the bounds are the world space bounding volume of the collider. I believe it comes from graphics. For example, if you look at the image, the green rectangle is a bounding box that describes where in the image the car lies. To find the coordinates of the sides, we can use this syntax. The bounds maximum x here is the x-coordinate of the upper right vertex. For example, the bounds minimum y is the y-coordinate of the lower left collider vertex. Let's translate all this into code. Open the drag icon script. Let's start with variables. First of all, let me create references to both colliders. The first field is a serialized field and refers to the icon collider. The second field will store a reference to the player field collider. To find the player field object, I will call the findObjectOfType methods inside the awake methods. And to assign the field collider, I have added the getComponents methods. The next three fields will store an icon's child objects, the frame, hero image, and background objects. I'm gonna rescale all child objects referring to the local scale property, which is a member of the transform class, so all of these fields are of rect transform type. Okay, let me enable the getIntersectionArea methods. We're gonna calculate area, so the method returns the value of float type. The intersection area variable returned by the methods is also of float type. The initial value of the variable is 0. The next 4 lines calculate the coordinates of points A and C. Points A and C are the opposite vertices of the intersection area. Let's have a look at the syntax. The collider bounds max property returns top right vertex. The collider bounds minimum returns the bottom left vertex. Let's see it in Unity. Open the player field scripts. Let me add the reference to the box collider, call the variable player field collider, and I will add the onGizmos methods. The methods will draw 2 red spheres with a radius equal to 0.2. Let the centers of the spheres get the coordinates of the bounds maximum and bounds minimum vectors. Let's see where Unity will draw red spheres. Open Unity. Unity throws errors since I haven't assigned the collider to the serialized field. Let me do it. Drag the collider into the player collider field. OK. Unity has drawn the spheres at 2 opposite vertices. Make sure that the Gizmos button is active. I hope it's clear. The bounds maximum and bounds minimum return the coordinates of upper right and bottom left vertices respectively. Let's go ahead. Open the player field script. Let me delete the onDrawGizmos method and go to the drag icon scripts. So the x1 float defines the x coordinate of the upper right vertex of the intersection area. As you remember, we have 2 options. The icon may enter the player field collider from both sides, but in any case we need to choose the minimum value. The y1 variable defines the y coordinate of the upper right vertex. The x2 and y2 variables are the coordinates of the lower left vertex of the intersection area. This time we have to take the maximum value. The important point here is that when we refer to the collider bounds property, we get global coordinates. The float numbers we have calculated represents the global coordinates of the collider's vertices. The rect transform component defines width and height based on local coordinates, since the icon and player field objects are child objects. So even if we calculate the area of the icon object referring to the rect transform, we cannot directly compare the value calculated with the area of the box collider. That's why I will continue calculating the intersection area referring to the box colliders, just to make it easier to compare objects' areas. It remains to calculate the width and height of the intersection area. It's easy. We just need to subtract the coordinates of the bottom point from the coordinates of the top point. The intersection area will be equal to the product of width and height. Okay, that's it. We have calculated the intersection area. We can compare this value with the size of the icon collider. The intersection area will never be bigger than the icon collider's size. Let me declare a variable of float type, call it icon collider area. We already know how to calculate the box collider area. I will do it inside the start method. First of all, let me find its width and height. I'm gonna refer to the bounds of the icon collider. The last line calculates the product of the width and height. I can get the same result without declaring the width and height variables, like this. Let's find the onTrigger stay2d method. Let me delete the print method. I will resize the icon while it is inside the field collider. Let me declare a variable of float type. Its value will be equal to the intersection area returned by the getIntersectionArea method. If the ratio between the intersection area and the icon collider's size will be less than, for example, 0.95, we will continue to reduce the size of the icon. The else statement will destroy the icon object. For now, let me just send a message to the console. Let's see how that ratio changes. Open Unity. I guess I need to assign the box collider to the icon collider field. Okay, hit play, drag any icon. I'll try to do it slowly. Okay, great. We see the ratio between the intersection area and the icon collider area. The further the icon penetrates the fields, the bigger this ratio. It remains to rescale the icon object. Open the icon prefab. Let me drag the child object to the corresponding fields. Good. Open the drag icon script. I'm gonna add scale down child objects method. The method has only one parameter of float type. I have called it rescale factor. We're gonna calculate its value a bit later. To get access to the scale property of the rect transform components, I'm gonna refer to the local scale property. The local scale is a member of the transform class, since the rect transform inherits from the transform class, and the local scale is a public variable. We can use it to rescale the rect transform for all child objects. I haven't yet declared the initial scale vector. Let me do it. Its initial value is equal to the unit vector. I'm not going to resize the rect transform of the parent object, so I can refer to the local scale property of the parent object. I'll do it inside the awake methods. All coordinates of the initial image scale are equal to 1. The rescale factor will get coordinates depending on the icon penetration into the field collider, but all of the coordinates are in the range from 0 to 1. Let's call the scale down methods. Back to the onTrigger stay methods. Let me add the scale down child objects methods. The argument here will be equal to the difference between 1 and the ratio between intersection area and the area of the icon collider. The further the icon penetrates, the greater the value of the parameter. The greater the value of the parameter, the smaller the size of the image. Nothing complicated. Let's check it out. Open Unity, hit play, pick any icon. Okay, Unity has resized the icon. Cool. It's not over yet, we still have some issues to handle. One of them is that we need to destroy the icon when it almost completely penetrates the field collider. Let's do it before we have a rest. Open the drag icon script. Let me add the destroy methods. Okay. Using hard numbers is not in line with the best practices. My experienced colleagues would tell me that I'm an unprincipled programmer. Let me declare a variable of float type, call it reduction limits, and let me replace the hard numbers with the variable. Open Unity, let's assign value to the reduction limit field. Okay, run the play mode. Good, now it is a bit better. In the next video, we'll refactor the code just a bit, we'll make the code look a bit more professional. We're gonna talk about extension methods. See you in the next video.